Okay, well, it's a very easy substitution, especially if you don't skip steps and screw it up like I did. Had the ME in the wrong place here, and almost did a couple other things kind of stupidly. But it's very clear that if you do this and do the algebra carefully, you come out with this, and it's very simple algebra, okay? So we now know what the wavelength is in terms of R, okay? And we know that the circumference is 2 pi r. There should be then radii, if you just think in terms of proportionality, which I ask you to do, there should be radii where this expression and this expression match up in pretty much any way you want them to, especially in the way that gives you a whole number of wavelengths within the circumference, because that's your criterion. If you've got a whole number of wavelengths around your circumference, if you've got a peak at this point, then if you have a whole number of wavelengths around to here, you're going to have a peak here. It's going to match up. Okay? The wave's going to match. And that should be pretty clear and pretty obvious in terms of what we've been talking about with waves. Okay? So now my question is, algebraically, what are the conditions for some whole number of these to fit within this? And why should we expect that that's actually going to be the case? I'm going to start with the second question. Why would we expect this is actually the case? Okay? How does wavelength depend on R? Is it linear? Well, what about 2 pi r? Is it linear? Okay, now we do need to think in terms of what linearity means. Okay? If I was to graph this versus R, would I have a straight line? Yes, I would have a straight line through the origin with a slope of 2 pi. Okay?
Right.
Are we oriented?
Yeah.
Now if I was to graph this versus R, well, all these things are constants. All we have is an R here, right? What can you tell me about that R? Well, it's inside the radical, right?
Yeah,
So if I was to graph this versus R, what would the graph look like?
It'd be a half parabola.
Yeah, exactly. Okay? So you know. But when I ask, are these linear? Okay, you need to think in terms of, is this linear? How does this differ from linear? Is it exponential? Is it a power function? Does it get bigger? Does it get smaller when R gets bigger? Right? Just, you know, all the functions you learned in pre-calculus, and then the calculus you know about them, and then your ability to throw that into multi-dimensions using multi-dimensional, multivariable calculus. Okay? You know all that stuff. But this simple middle school question of proportionality, since it never gets taught in middle school or anywhere else, is not something you naturally think in terms of, and we want to get in the habit. Okay?